Hey, hello all. Welcome to Clojure Diary. So, today, we are. That is like I'm very happy to say that. Okay, look, I'm venturing into data science domain with Clojure. Right. Look, Clojure seems to be very perfect language compared to Julia and Ruby and even Python. As a programmer, I can feel that. Okay, so and I wanted to do data science with that because like data science and web development are kind of two things that earn me bread and butter. But now, yeah, it's more of web development. But yeah, I'd like to explore data science too. So, like today, we are going to see this something like a hello world of data science. We are going to classify this iris data set. Okay, so iris is nothing but iris flower. Okay, so iris is nothing but it is some kind of flower, right? So if you go to Wikipedia, you can see about it. I'm not sure my internet is working or it's gone. I don't know. For some reason, the Mac internet on Mac seems to be really slow and all those stuff. Okay, yeah. Thankfully, it worked. Okay, yeah, it is a flower like this, and if you take a look at this, the violet thing and all these things are called as petal. And I think this, I don't know what's really sepal in this. Okay, let me tell what petal and sepal are meant in a flower. Okay, so this is a flower. Okay, so the yellow thing is called petal. Okay, so that's the thing. And oops, yeah, the yellow thing is called a petal, and the green thing that's below the petal. If you take a look at flower, I think you should be able to see. Hopefully, even in countries where it's really cold or desert, I think humans are growing flowers like inside their homes or something. So hopefully, I guess everybody understands. So like the green thing that's below the flower is called as sepal. Okay, so this green thing. Okay, so let me just expand it. Okay, so this green stuff over here, like this is called as sepal. Hopefully you can see my cursor, right? The yellow thing is called as petal. Okay, so that's how it is. So looks like some humans have measured what is the length of petal and sepal in different species of iris. Okay, so this is iris plant. So this purple thing is called as petal. I don't know what is sepal. Like I don't know whether it's shown properly or something. I'm not sure, right? So I really not sure. Okay, maybe this green thing is sepal. I don't know, right? So I'm not a botanist, but somebody has made all those measurements, and they have put it in a CSV. And okay, when they made measurements, I think it was even before computers, or even possibly even before electricity became prevalent. I'm not sure. So they have put it, they've cataloged it, and today, like all these data scientists are using this data to learn data science or explain data science. Okay, so today we'll what we will do is our project is like this thing. So we will take two values like the petal length and sepal length. Okay, so that's the thing, right? And okay, and what we will do is like with that we will try to say which species of iris it is. Okay, so that's how it is. So how are we going to do that? Okay, so we have got this data, and how are we going to do that? Okay, okay, and this is also I've taken it from internet. I'll put this URL or something like that. So this is from some other project done by somebody else, and he has put this image on it. Right? So um, a lot of data scientists have pointed, what to say, plotted all the parameters of iris that can be plotted. Okay, so you have this sepal length. Okay, like if I take sepal length, sepal width, petal length, and petal width. Okay, so let's say like okay, like they have plotted like sepal length versus petal width. Okay, so if you see like you can say like okay, like at the bottom is blue is being clustered, and middle is green, and at the top is red or something like that. Okay, so and over here and over here okay, and over here you've got the labels. Okay, the blue is called as setosa, and the green is called versicolor, and the red is called virginica. So these are all some names like some English guy or some European guy have given. Okay, so that's the thing. and I don't know the real meaning of those names and all those things. But yeah, like uh, we can use this data to what to say. Uh, Find the species of iris. Okay, so let me tell you how it works. Okay, so this algorithm is called as k nearest neighbor. Okay, so what we're just going to do is, okay, we have this petal length on x-axis, and you just see this graph, right? And you just have sepal length in y-axis. Why I chose this graph is like this graph to my eyes. Okay, like I don't say like I'm right. This graph to my eyes looks quite uncluttered in this two dimension. Okay, so you have this red dots over here. I think the red dots are Virginica, and the green is versicolor, and this one is Setosa. So I feel like, okay, this graph separates stuff more clearly. Okay, so I'm going to use like this petal length exhibited in x-axis and sepal length exhibited in y-axis to determine the iris species. Okay, so that's what I'm just going to do. All right. Okay, so the code for that is over here. Okay, so yeah. So let me tell you what I'm doing. Okay, so like okay, first there is this iris.csv, right? So okay, yeah, let me just take this code and let me just put it. Okay, okay. First, let me just execute this file. Okay, so let me just execute this file. Okay, like this snippet of code, right? So it shows nil. Okay, so this if this thing shows nil, I think we are all okay, right? So right, okay. So this thing executes as nil. If you want to do it again, yeah, executes as nil, and you have this thing called column to number. Yeah, I'll explain it what. Okay, so that's the thing. So let me just copy this block and let me just execute it. What to say over here, right? So okay, it's over here, right? Okay, so okay. So now what I'm just doing is, yeah, let me just put it over here and let me just comment all this stuff. Okay, so right. Oops, but I need to have this one over here. Okay. Okay, so what I'm just doing is like iris.csv is there. Okay, this is the file name, and this file is right over here in this project. Okay, I'll put the link of projects and all those stuff. Okay, so that like you'll be able to reconstruct it. Okay, so iris.csv is there, and now I'm just slurping it. Slurping is nothing but reading the file. Okay, so like okay, so now you have just got like okay, this one I need to wrap text. Okay, so wrap, yeah, toggle. This is not working. Okay, fine. Yeah, so if you just slurp it, look, all these things, okay, so, and even the new lines are being printed as slash n, okay, so, yeah, now we have just got it. Then, what I've done is like in project.clg, this is a Leningen project, okay, so some people are telling me to go with depths.enn, but this is the thing I just know. Look, I'm just a Clojure learner, and I can just say like I'm just amateur in Clojure. So that's the thing, and so I just found this library CSV map. If you go to Clojure and see, you'll see it. So what this does is this gives a function called parse CSV. So let me just uncomment this line. Okay, so it gives this function parse CSV, and let me just execute it. This converts this stuff into a map. Okay, so I think a list of map. So look at the difference. Okay, so over here is just one big mess of a string. Okay, so and look, now we have got the species setosa, petal width is this much, petal length is this much, blah 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 blah, sepal length and sepal width. Okay, so that's the thing. But then we are facing one problem. Okay, so these things are all in string. Okay, so this sepal width, petal width, sepal and petal, and they are all in string. Okay, so this parse CSV doesn't have any idea. Like this is not a thing that's been created like for data science so that like you can identify this as number and convert this to number. Look, I think there is a library called tablecloth in Clojure that does it, that has the intelligence. But look, we are just learning data science in Clojure. Okay, so like so if you excuse me, yeah. So that's the thing. So there is this function called column to number. So let me just load it into memory, right? And if I just do this, okay, now I just want to convert the sepal length into number. Okay, so let me just do that. And where is the supplement? Yeah, now it's 4.4. It's no more, what to say, this quote, something like this 3.0 or something over here. Now it's 4.4. Now it's just a number. So similarly, what I'm just doing is every column, I'm just converting it to a number. Okay, so that's the thing, right? So that's what I'm just doing. And okay. And okay. Hope I don't remove some brackets or something like that. Okay, yeah, fine. So let me just tell you how this column to number works. So first you get this data. So okay, so over here we are just passing this thread last. So the iris.csv gets passed to slurp. The output of the slurp gets passed to this thing CSV. This is, sorry, I think we are doing thread first. Okay, so that's the thing. So and over here, this output of this gets passed over here between this column number and the sepal length. So it get passed over here. So you can't see that, but it get passed over here. Uh, so it get passed, this entire thing, this entire stuff get passed over to this one. Okay, so first what happens is, like, okay, it takes in the data and the column. Okay, so and believe it or not, this thing was being coded by what to say, GitHub Copilot. So it somehow did it. Okay, so I just specified this one and it just gave this one, right? So it just, I think this one is a thing in Java. So double parse double, and it just takes this column. Okay, so this is the data. This takes each and every row in data. So it just takes this row. Let's say it just takes this row, right? And if the column is sepal length, okay, so it just takes the data and the sepal length. Okay, so you get the sepal length out, and then it associates this one. Okay, so okay, it just takes this one out. Okay, the sepal. Okay, so yeah, it takes this phi out. So here you'll just get phi out over here, and then it converts into a double. That means it will become phi, a number phi, not a string 5.0, right? Then it associates that same column. So okay, what is it? It associates the sepal length to the number phi and not string phi. So what it does is it just takes this, converts this into double, and it just puts a double value over here. So finally you'll be getting something like this one. Okay, so that's what it's doing. So this is what I did to sepal length, and this entire thing, output of this one, gets passed over here. Similarly, sepal width, petal width, petal length, and petal width, everything gets converted into, what to say, a number. That is a double, right? So double is better rather than, because the precision will be good. So, and we finally store it in a variable called data. So that's the thing, and I can just show this variable over here. So every what to say, like, thing is being converted into a number over here. So every conceivable column that has a number gets converted to a number, right? So that's the thing. And now in this function, right, what I'm just doing is I'm just computing the distance. Okay, like let's say, like, okay, okay, let me just explain this data with distance. Okay, so right, okay, so what it does is, okay, let me just take the first thing of data. Okay, just one row. Okay, so def one row. Okay, so, and let me just take first data. Okay, so you've just got it. So one row. Okay, so that's the thing. Okay, so let me, I think, put it into a list. Okay, so let me just reframe it, or let me just put it into a vector. Okay, so it'll be like this one. So one row. Okay, I'll tell you why I put it into a vector. So because it's because of this map. This map thing, it will only take a vector. Okay, so that's the thing. So what I'm just doing is, like, okay, I'm just giving a point. Okay, data with distance. Okay, so and then what I'm just doing is giving a point. Okay, let's take a point over here. Okay, 1 comma 5. Okay, so So the petal length is 1 and sepal length is 5. Okay, so 1, 5, and then data, right? So that's what happens. And uh, oops, I did it for data. Okay, I should do it for one row, right? So one row. Okay, so what happens is, okay, this computes the distance over here, right? So that's what it does. And let me give something that's far, far away, like, okay, 7 comma 7.7. Okay, right? So let me just take it like 7 and 7.7, right? So if you just see that the distance over here is enormous, okay, so definitely if you, it's okay. So this species is Setosa, but the distance is very far away. So let's say like you're in Sydney and somebody lives just 10 meters away from you, and I'm kind of like, what to say, hundreds of kilometers away from Sydney. So does a person living 10 meters away from you, or is in Sydney, or like somebody living hundreds of kilometers away from you is in Sydney? Definitely a person who's near to you is in Sydney or something like that. Okay, so definitely this dimensions means, okay, it means more of Setosa than these dimensions. Okay, so let's say you just take an iris flower and you just measure it and put these things, it's far, far away from Setosa. Okay, so that's the thing. So this is what actually KNN does. Okay, so okay, so let me explain this function for the people who like to know about it. So what I'm just doing is like I'm just taking petal length as first point. So it'll be okay. Let's say it'll be 1, and the sepal length will be the second. So it'll be 5. Okay. So what I'm just doing is like I'm just uh putting a to say like, okay, forget about this one right now, right? So okay, I'm just doing this thing like LPD vector distance. This is nothing but okay, like I have a program called LP distance. Okay, so and it is over here. And to know about this, I won't be explaining it over here because like because I've already done it on my blogs. Okay, so you go over here, you can see this vector distance in Clojure. Okay, so I have explained this one. So what this does is like, okay, like in short, okay, if there is a point over here or something like that, it measures the distance. Okay, let's say there is a point over here, right, somewhere over here, like 2,6. Okay, it measures the distance between this and this blue point. If you give this blue point, it measures this distance and it just gives. Okay, so that's what this function does. So please go and look at those video if you want. So yeah, this measures the distance of this petal length and sepal length. Okay, that's been passed as a vector to that. And over here in data, we are, okay, this first row of data we are getting, and we are getting the data petal length and sepal length. Okay, so that distance we are just computing, and what we are doing is to this data itself, we are appending a keyword called distance, and what we are just doing is like we are just appending distance over here, right? So that's the thing. So the distance gets calculated and gets appended over here, right? So that's it. So okay, this worked for one row and this also worked for 1,000 rows. Okay, so but in reality we are not having like thousands of rows and all those stuff. We are only having like 151 rows or something. Okay, so that's the thing. So yeah, so and what we are doing over here is, right, so say, okay, like let me just copy this, put it over here, and then okay, put this over here and comment it, right? Okay, so what we are just doing is, okay, 1 comma 5 is there, and we are what to say, doing this data with distance. Okay, so that's what we are just doing. So for everything, this distance has been appended. Okay, look at for Setosa, it's 0.8 and something like that. And okay, we are only seeing Setosa. I don't know what about this. Okay, so okay, never mind. Okay, so I don't know. Okay, so I thought we'll be able to see everything over here, but over here the triple dot means, okay, like some rows are not being showed because it's too big or something like that. Okay, So now what we are just doing is now we are just sorting by distance, right? So yeah, we just sorted by distance, right? And so yeah, so this 1.19 or zero point 0.2 is lesser than zero point 0.3, and that is almost lesser than zero point 0.4 over here, and all those stuff. So, and we are just sorting by distance, and we are just only taking 5 out of it, the first 5 out of it. So whichever has least distance, we are just taking it. So 1 comma 5 is nothing but like, okay, it's something over here, 1 and 5. So definitely this Setosa stuff will dominate. Okay, so you're getting the least distance. Okay, so we're just taking 5 out of it, right? So everything is Setosa. Okay, so and now what we're just doing is like we're just getting the species out of it, right? So everything is Setosa. So the least distance is Setosa. So it's intuitive, right? So very intuitive. But yeah, we to computer we need to tell everything. So we are just getting the frequencies of it. So it's just Setosa 5, right? Okay, so that's the thing, right? And then we are just sorting by values. Okay, so this is sort by val. Okay, so it'll take the values of frequency and it'll sort. Okay, so okay, so now let me just execute it. Okay, so now is this Setosa phi and all those things, and so let's say if we have something like Virginica or something like that, let its thing be 1 and Setosa just be 4. Okay, so we need to get the greatest, right? So the Virginica 1 will be at the front and Setosa 5 will be at the last. Okay, because there'll be or the Setosa 4 will be at the last if we take 5. Okay, so we need to get the last one because we need to get which one has the maximum, which labels are the maximum. Okay, so we are just getting the last one. Okay, so of course it is this one over here, and since the Setosa value is first in this and phi is the second value in this, we just want to get that. Okay, so in Clojure you need to have idea of the data structure what you're passing, right? So that's the thing. Okay, so yes, so this is how this thing works step by step. I think I explained it properly and all those things. Okay, so and this very same thing till up to take 5 I have put it over here, right? So but I think yeah, this is more intuitive for me. But yeah, you can even what to say work out with this and do that. Okay, so now let us change stuff and what to say, give it like let's put a value of 6 comma 7, right? 6 comma 7, right? So 6 and 7, right? So okay, so let me just execute it. It says Virginica, like, right? Yeah, 6 7, it's something somewhere over here, and it's red. Okay, red is nothing but Virginica, right? And let's try something in green. Okay, so let's say like 4 and 5.9. Okay, so 4 and 5.9, right? 4 and 5.9, right? Versicolor, right? The green is versicolor, right? The green is versicolor, yeah. So that's how this thing works. So I hope, yeah, you just understood what I explained and all those things. But yeah, if you don't, yeah, please comment. There've almost been no comments in my videos, so please comment. And yeah, like I think in coming days I'll be exploring more and more about like Clojure data science and Clojure web development and all those things. And of course, like some people have said, like, okay, this my videos are not so professional. Definitely, it's not professional because I'm just learning Clojure, and I think there are some paid Clojure classes offered by somebody, and you can take that. But I just want to document my learning, so that's why I've just put these videos, and that's why I've named it like Clojure Diary. Okay, so it's not like what to say, the perfect Clojure manual or something like that. Okay, so that's the thing. But yeah, I think this would help some people, right? So yeah, that's how it is. And yeah, and do put comments, like do put understandable comments so that like I can read it and possibly answer to that and possibly make another video and something like that. But I don't know when I'll make because uh, So yeah, that's the thing. Anyway, thanks for watching my videos. I hope like it helps you.